If you work in finance, Excel probably feels like home. Forecast models, sensitivity analyses, nested if statements, maybe even a bit of VBA coding. But here's the uncomfortable truth. Excel is not a modeling engine or a database substitute. It's a spreadsheet. And the more complex your model becomes, the more fragile it gets. Hidden logic, circular references, broken formulas no one wants to touch. I myself used to build everything in Excel until I started using AI to structure the modeling logic instead. In this video, I'll show you how to rebuild a financial model using Claude Code, not to replace Excel entirely, but to move the logic out of fragile cells and into something structured, auditable, and scalable. Excel became the default modeling tool for finance for a reason. It's visual, it's flexible, it's immediate. You can build a three-statement model, link sheets together, run a sensitivity analysis, and adjust assumptions in seconds. For many finance professionals, Excel isn't just a tool, it's an extension of how we think. Rows are timeliness, columns are scenarios, sheets are logic layers. And to be clear, Excel is incredibly powerful. The problem isn't that Excel is bad. The problem is what we've started using it for. Let's talk about what happens when a model grows. You start simple. Revenue growth assumption, cost structure, cash flow projection. Then you add debt schedules, scenario toggles, working capital adjustments, dynamic tax logic, and suddenly the model becomes delicate. You see nested if statements, 5 layers deep, hard-coded assumptions hidden in random cells, circular references that technically converge, macros nobody wants to touch, multiple file versions floating around. The model still works, but the logic is buried. And when logic is buried inside cells, complexity scales silently. You don't see the structure anymore. You just see outputs. And that's fragile. Here's the conceptual shift. Modeling is not the same thing as calculation. Modeling is defining assumptions, defining rules, defining how variables interact, defining what happens when something changes. Excel mixes assumptions, rules, calculation, and presentation into the same layer. A single formula might reference 3 sheets, embed a business rule, apply a constraint, and output a formatted number. All in one place. That's convenient early on. But as complexity grows, your logic becomes implicit instead of explicit. And implicit logic is hard to audit, hard to scale, and hard to transfer. Let me walk you through a real example. I have a dividend tracking model which I created in Excel. It worked alright. I downloaded CSV from my broker Avanza, then used functions in Excel to calculate tax, including foreign withholding tax, charting dividend growth over time, and so on. As I said, it works fine and has worked for years. But every time I added a new holding, I was manually updating ranges. Every time the CSV format changed slightly, something broke. And the chart formatting, I'll spare you the details. In other words, though some things could be automated, my model was still quite rather manual. So I opened the AI tool Claude Code and described what I wanted. In plain English. No syntax, no code, no functional references, just what the model needs to do. I told it, I have a CSV from Avanza. I want to see dividend growth over time, tax calculations including foreign withholding, and I want the data stored in SQLite, not in the file itself. The move to using a database, SQLite in this case, is crucial here. Many people use Excel as a database, but it's a spreadsheet. As your data grows, the file becomes slow to load, and at some point, you won't be able to add more data into it. Finding data or querying Excel is quite difficult. With a database, size stops being an issue, and acquiring it is quite simple. I chose SQLite, but there are many other alternatives for your database setup. This is the key architectural shift. In Excel, your data, your logic, and your presentation are all tangled together. When you separate them, data in SQLite, logic in Python, presentation in a GUI, a graphical user interface, each layer can change independently. You can update the chart without touching the calculation. You can swap the data source without rebuilding the model. You can add a new scenario without breaking the existing one. With an interface, which I will talk about in the next segment, you can have functions doing the queries, something AI can create for you. I asked Claude Code to create a dashboard to make the dividend model easier to overview. I wanted to easily filter and switch between different types of visuals, something that was previously solved using different sheets and VLOOKUPs and so on in Excel. Again, I am not bashing Excel, but I'm saying it was never intended to be used in the way I and others are using it. In terms of pivoting and visualization possibilities, it is lacking. Let's be honest about that. Let's go back to the new dashboard Claude Code made for me. To use it, you load the file, the data goes into SQLite, and you get the interactive charts. Dividend by stock, dividend by year, and tax breakdown. The logic lives in Python code. Readable, version controllable, testable. The assumptions are explicit, not buried in a cell 3 sheets away. If I want to add functionality or change something, it's a prompt away. As you may have gathered, this has indeed saved me hours. Now imagine the amount of time it saves in other types of settings and with other types of processes. Does it help that I know how to code? Yes. Is it a prerequisite? Not at all. My coding skills help me check for bugs and issues and plan the project quicker, possibly. But these are skills you can learn. And if you don't want to, you can still use Claude Code to create projects like my dividend model and even better ones. To get you started with prompting AI tools effectively, check out my video about prompt engineering. And if you actually do want to start learning how to code, check out my video, How to Think Like a Coder. Here's something important I want you to understand. You're not writing this code. Claude Code writes it for you. You describe what you want, it builds it. And if it's not right, you tell it what to change. In plain English, your job is structured thinking, knowing what the model needs to do. The AI handles the implementation. So what does all this change in practice? How is this an upgrade? First, version control. Your model is code. Version control systems like Git tracks every change. You can see exactly who changed what assumption and when. Try doing that with Excel. Second, data integrity. Your raw data sits in SQLite or similar databases, untouched. The model reads from it. You're never accidentally overwriting source data. Third, auditability. Every rule is written out explicitly. If someone asks why the tax calculation works a certain way, you can show them the function, not hunt through 8 nested ifs. You can also ask the AI tool to add comments in the code, so you and other users understand which functions does what, so you can prompt for updates easier in the future. Fourth, scalability. Adding a new portfolio position doesn't mean updating named ranges. Adding a new scenario doesn't mean duplicating a sheet. You extend the logic. Adding more data does not make this solution slower, and it doesn't have a size limit. Fifth, and in my mind, the most important one, automation. Manual tasks and data cleaning I had to do myself is now done automatically in the background using code. And the user experience? You get a natural interface, drop-downs, filters, chart that updates dynamically. And to be honest, it's aesthetically more pleasing to the eye. Again, let me be clear. Excel is not obsolete. Excel is still excellent for quick analysis, ad hoc modeling, a quick visualization of data using pivots, a quick way to test out ideas during a meeting using Excel as a scratchboard. But when your financial models start becoming strategic assets, when other people depend on them, when the stakes get higher, the logic deserves structure. Even for personal projects like my dividend model, moving out of Excel is a win in terms of giving me a much better overview of my trading portfolio and time saved. AI tools like Claude Code and Codex don't replace finance professionals. They amplify structured thinking. Excel made finance professionals powerful. Structured modeling will make them future-proof. If this was useful, subscribe. I'll keep exploring how business and technical thinking can work together. See you in the next one.